So today we're going to talk about measures of variation. So the shape of the distribution describes the variation qualitatively. We talked about the shapes of the distributions in the last section. So here are some of the quantitative measures of variation. First one's going to be range. So the range of a set of data values is the difference between its highest and lowest data values. The range is going to be the highest minus the lowest. And we can do a 5-number summary. So this is one of the things that you heard me discuss about Project 2, right? So you got to do the 5-number summary. So you might not have known yet what to do with that, and now you will. So for that, it divides, the median divides the data set into 2 halves, and then the first quartile will be the median of the lower half. The third quartile is the median of the upper half, and then it also includes the minimum and the max. So you'll have the min, the quartile 1, the median, the quartile 3, and the maximum. And quartile is just a way of saying the quarter. Like basically you cut it into halves and then you're cutting it into fourths. So that's what those quartiles mean. And we can display the 5-number summary with a graph. It's called a box plot, and we heard me mention that word when we're talking about the next activity. You're going to create a box plot and a whisker plot. A box and whisker plot. We're going to determine the values of the 5-number summary. We'll draw a number line. We'll mark the values of quartile 1, median, and quartile 3. And then we'll also add min and max on there. We'll draw a box around those quartile 1, median, and quartile 3. And then these are going to be the whiskers. So here's your box, and here are your whiskers, okay? If we want, we can show this in a little bit bigger picture. So here's the box part. These are the whiskers. You can put them above the number line, or you can put it on. Typically, what you're going to see me do is draw it on it versus above it, but I don't care either way, all right? And on a test, I'll give you like a number line to work with. You'll put on your own numbers, but I'll give you a line at which you can work that. All right, so let's go. Oh, our exam scores are back. So we're going to consider the following set of 20 scores on a 100-point exam. Now, I've already put them in numerical order because we've already done that a couple of times, and you need them in numerical order in order to do your 5-number summary. In order to find that median, you're going to have that middle number, okay? So we're going to find the range in the 5-number summary for the exam grades. And then create a box and whisker plot. All right, so we are in section of 4.3. And we're on example 1. So I'm going to make sure I make my list a little bit, I'm going to start a little further to the left. So I need 72 3 times. And then 74, and 75, 75, 76, 76, 77, trying not to go slanty, 78, 79, 80, 81, 84, 86, 88, 88, 91, 94, and 98. All right, good. I got them all in one line. Okay, so what we need to do first is find our, it said to find the range, right? So let's go find our range. Our range, again, is going to be our max minus our min. So 98 minus 72 will get us a range of 26. Now, what I want to do is find my values, okay? So I know that I've got to find the median. So if I'm looking at my 2 numbers here, remember we've already found the median for this. So we're going to go in, we've got 20 numbers. If I divide that by 2, I get to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this gets me the 2 numbers that I'm looking at, right here. I've got to find my median, and I've got the 2 number part. So the median is going to be 78 plus 79 divided by 2 gets us 157 divided by 2 gets me 78.5. So there's my median. All right, now I need to find the median of the bottom and the median of the top. All right, so my median is landing, this is my median here in the middle, right? So this number is not included in my median because it's not actually the median. It's the median is in between. So I still have 10 numbers down here. Well, 10 is another even set, right? So 10 divided by 2 would be 5. So 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. This is going to be the 2 numbers I look at for this. Now, they happen to be the same number, but I'm going to do the same math so that you can see what we would do. So for quartile 1, I'm finding the median. I'm going to have 75 plus 75 divided by 2. 150 divided by 2 will be 75. Now we knew it was going to be 75 because it's the same numbers, right? So my quartile 1 is landing right there. Now I need to go find my quartile 3. So again, I have 10 numbers. So divide by 2 is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That gets me these 2 numbers. So my quartile 3 is going to be there. Now, I have 86 and 88, so it's probably going to be 87, right? So quartile 3 will be equal to 86 plus 88 divided by 2. When I add those, I get 174 divided by 2, and I get 87. No surprise because it's the middle number in between those. All right, now I have 2 more values. I need my min, my lowest number, and my max. All right, so those are just going to be the end numbers. You don't have to do any calculations for that. So the summary would be, if I'm doing the 5-number summary, just so if you were like, hey, I need to do the summary on this, this would be my min, my quartile 1, my median, my quartile 3, and my max. All right, so 72 was my min, my quartile 1 was 75, my median is 78.5, my quartile 3 is 87, and my max is 98. So this would be the 5-number summary. This is showing all of my work, but if I want to do the actual summary, that's what it's going to look like. Now, from this summary, I'm going to make a box and whisker plot. Okay? So, I know that I'm starting at 72 and I'm going up to 98, but I like to make those even increments just like we've been doing. So I'm going to start at 70 and I'm going to go in increments of 5. So 75, 80, 85, 90, 95, and 100. Now, those aren't necessarily any of the numbers I have here, but I need a scale that I can use. So now my min is at 72, so just try to get it to where 72 would be, and I'm going to label that. And I'm going to also label that it's my min. My quartile 1 is on 75, and then my median is at 78.5. And then my quartile 3 is at 87. And then the max is at 98. Now, we talked about we're going to create a box right here, and then I'm going to have whiskers that go here. So label each of the numbers so I can tell that you know what those numbers are. Now the 75 I did not rewrite because it's right on the line there. And then label up above, okay? And make sure you draw the whiskers. All right, so that's the box and whisker plot. That goes to our exam scores. All right, now that was one that had a bunch of even numbers, right? Or even quantities. As far as we had 20 and then we split it and it was 10. Let's go look at a similar one, but we're going to have less scores because I need to have something that is more of an odd. Okay, so let's go look at example 2. So consider the following set of 15 scores on a 100-point exam. So we've got 72 all the way up to 98. So our range is still going to be the same, but it's going to be a little bit different. All right, so this will be example 2. And let's find our range again. Our range is still going to be 98 minus 72. Still gets us a range value of 26. That's how spread out the points are. And our values are 72, 74, 75, 76, 77, 78, 79, 80, 81, 84, 86, 88, 91, 94, and 98. So again, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Make sure I have all of my points. So I need to find my median. All right, so 15 divided by 2 is about 7.5, right? Because 14 would be 7, 16 would be 8. All right, so 1, 2, 3, 4, 5, 6, 7. If I go there, and 1, 2, 3, 4, 5, 6, 7 on both sides, this middle number of 80, that is my median. So it's going to be the 8th number. There's 7 on either side. Now, when I find the median down here, I don't include that number because it is the actual median. It's not a number in between. So now I have 7 numbers down here. If I divide that in half, I basically have between a 3 and a 4, right? Because 3 would be 6 numbers, 4 would be 8, so about 3.5. So it's going to be 1, 2, 3 on this side, 1, 2, 3 on that side. It's going to be my 4th number in. This will be my quartile 1. Same thing on this side. I have 7 numbers. So 1, 2, 3, 4th number in, 1, 2, 3, 4th number in. So this will be my quartile 3. Sorry, I got a frog in my throat. And so the thing we need still is our min and our max. So we didn't have to do any math this time. We just, except for counting, right? So the odds are going to be a little bit easier and a little bit faster. All right, so for our 5-number summary, we're going to have our min, our quartile 1, our median, our quartile 3, and our max. So the min is 72. Our quartile 1 is 76. Our median is 80. Our quartile 3 is 88. And our max is 98. So that is our 5-number summary. Now let's take our 5-number summary and do a box and whisker plot. So we got a number line again. We're going to start same spot, 70 and 75 and 80 and 85 and 90 and 95 and 100. Okay? All right. So 72 is our min still. So this will be our min. Still going to label it at 72. Our quartile 1 now is 76 because I changed the numbers. Our median is now 80. Our quartile 3 is 88. And our max is 98. Okay? All right, let's go back, and those middle 3 values, we're going to make our box, and then we got to color our whiskers on there. So again, this is our box and whisker plot. Okay? So hopefully that's giving you a good clue about how to do 2 box and whiskers. And now you can understand with the even values versus the odd set of data, right? So it's not really the values, it's the amount of data points you have. All right. And it took less space to do this because we didn't have to do as much math, because there's your whole problem in our half sheet there. All right, so now we're going to talk about percentile of data value. It's the number of values less than this data value over the total number of values in a data set. All right, and then we're going to multiply by 100. So a data set consists of the ages of 87 female actors at the time they won an Academy Award. One of the women was 50 years old, and she was older than 77 of the other winners. What is the percentile of the age of 50? All right, so this will be example 3. We're at part A. All right, so she was 50 years old, but she was older than 77 of the other winners. So there were 77 other winners that she was older than out of a total of 87. Put that in the calculator, we get 0.885. Multiply that by 100, so basically move your decimal place over, oh, you cannot see, I'm so sorry. So 77 over 87, 0.885 will get us, as we multiply by 100, will get us 88.5, which we could round up to the 89th percentile. Okay. All right. Let's go to part B. One of the women was 25 years old, and she was older than 5 of the other winners. What is the percentile of the age of 25? So, she was older than 5 out of 87, which gets us 0.057. which will, if we multiply by 100, it'll get us to 5.7, which we can say is the 6th percentile. All right, next category. So not too many are winning at that young age, right? All right, one of the women was 80 years old, and she was older than 86 of the other winners. What is the percentile of the age of 80? All right, so she was older than 86 out of 87, which will get us 0.989. And if we multiply that by 100, it'll be 98.9. So 99th percentile. So being 80, put her in the very, very top category. Okay? So that's how you're going to find the percentiles of the data values. Now, the next one we're going to go on to is standard deviation. So standard deviation is a measure of how widely the data values are spread around the mean of the data. It is the single number most commonly used to describe variation. Ah, there's another little, hey, what's the number that's the single most commonly used to describe variation? That would be standard deviation. That would be like another good test question. So the standard deviation is found by the sum of the deviations from the mean squared divided by the total number of data values minus 1, and then you take the square root of it. So that's the formula in words. This is the formula in just the formula itself. All right, so first we'll compute the mean. We've done that on a few things. It's called X bar. We already know that. Then we'll take each data set, subtract the mean, and then we're going to square it. Then we'll add all the squares together to get this funny looking E part there that just means summation. And then we'll divide it by the n minus 1, and we're taking the square root of that. So let's go put some numbers to this so you can see how to do it. All right, so we've got a small set of values here, and we're talking about the cost of plane flights. So while planning for spring break, suppose you went to the orbitz.com and found the cheapest flight from Philadelphia to Orlando and found the following prices. We want to find the standard deviation of this data set. All right, so look at a new sheet because we're going to have a little bit of math here. So this will be example 4. All right, so I'm going to list our numbers first off so we know what we're working with. Okay, 1, 2, 3, 4, 5, 6 numbers. So the first thing that we have to do is find the mean. And the mean is that X bar. So we've got 195 plus 213 plus 208 plus 219 plus 210 plus 215. And we have 6 numbers, so we'll divide by 6. Our total, when we add up all of the values on the top part of our fraction here, is 1260 divided by 6 is 210. So there's our mean. Now we need to find the standard deviation. So just like when we've done the frequency chart, I'm going to do another chart because the chart makes it a little bit easier to do. So we're going to have our X value. So this will, and then we're going to have our X minus X bar. I'll leave a bit of space. And then we'll have our X minus X bar quantity squared. Trying not to write too slanted. I know these are going to have to be a little bit longer. All right, so we've got 195, we've got 213, 208, 219, 210, and 215. And just like we've done before, we're going to kind of square off our box here. And down here, I'm going to put some of the formula that we have. So I'm going to have a bit of a total here, down here. All right. Let me bring this up so it looks kind of like a box. So here's our data point. Here's our mean. So 195 minus 210 will get us negative 15. 213 minus 210 will get us 3. Right? Yes. 208 minus 210 will get us negative 2. 219 minus 210 will get us 9. And 210 minus 210 will get us 0. And 215 minus 210 will get us 5. All right, now we're going to take that number and square it. So negative 15 squared is 225. 3 squared will be 9. Negative 2 squared will be 4. 9 squared is 81. 0 squared is 0. And 5 squared is 25. Now, what we have to do is add all of our numbers up. So we're going to add our 225, our 9, our 4, our 81, the 0, and 25. So we're going to add those all together. That's what this means, is to sum it. So we're summing all of those together, and we're going to get 344. So that's the sum of this part. Now our formula, which was on our handout there, is S is equal to that square root of the summation of x minus x bar squared over n minus 1. All right, so we've got the summation right here. Our n is the same number of values we used to find the mean. We had 6 data values. So we're going to have the square root of 344 divided by our n of 6 minus 1. So the square root of 344 divided by 5, and 344 divided by 5 will get us 68.8, and I didn't round on that because you don't want to round. I actually found a 68.8. And you don't have to do this part. You can just take the square root of this whole thing if you want to do that. And then we'll take the square root of our 68.8 and we'll get 8.29. And there's a 4 after the 9, which is fine. So the 9 won't bump. But remember, we talked about significant values. We had all whole numbers, so we're going to make this 8.3, right? So that would be the standard deviation. And again, that talks about how far away from the mean the next numbers are. They're going to be about 8.3 away, within one standard deviation and with 2. All right. So that's finding the standard deviation. It's the same steps for each one of those. You just got to keep practicing over and over because you'll need to be able to do that. All right. So the range rule of thumb kind of gives you a range. It's an approximation related to the range of distribution. It's not always very good. It does not account for outliers. So the range rule of thumb does not work well when the high or low values are outliers. So you take the range divided by 4. So this is number 5. We're going to go back and use the same problem we just did, but we're going to use the range rule of thumb and then compare the estimates to the actual values found in, that should be saying example 4 there, not example 3. So we're looking at example 5. We're finding the range rule of thumb. So we're going to take our range of our values. That means we got to find the high one. So when we're looking at our data set, we've got 195. That looks like it's the low, and our high is 219. Now, one of the we'll look at more about those data values here in just a minute. So we're going to look at our range of values. So the range is 219 minus 195. and that'll get us 24. So that's our range. And what we want to do is find our range divided by 4. So 24 divided by 4 equals 6. Now you could have also done that all in one step. You could have done 219 minus 195 over 4, still get you 24 over 4, get you 6. You can separate it out or you can do it all in one. But you do have to show me that subtraction. So add, subtract, multiply, or divide. You want to write it in your homework and you want to write it on your exams. Okay? Now, why is this not 8.3? Well, let's go back up here and look at our data. When we look at the data here, all the rest are in the 200 level, right? We start out at our next small one is 208. This one is 195. So that's going to make a difference, right? Because that 195 is almost an outlier, right? Because it's 15 points away from our average. Notice the other ones were pretty small. The 19's a little up there too, but that one's quite a bit higher. So that's where if we didn't do the 195, if we didn't have such a low number, then that's pulling out everything, right? It's changing it quite a bit. So it moves things because our range is up to 24. Just that one data point changes it. So that's where it's an estimate, and on some estimates it will be closer, but in this case it's not closer than this one because it's not just a nice normal distribution where there's a little bit. And the 195 isn't a huge outlier, but it is a little bit of one. But it can be a way to estimate what's going on. All right, we have another question, and our last question, I believe, in this set is our does it make sense? So I examined the data carefully, and the standard deviation was greater than the range. So the standard deviation was greater than the range. So let's go look at our problem. Our range, we can look at this last problem. Let's go find the range real quick. We'll add this in. So this will be example 6. We're going to find the range for our previous problem because that's what we have as far as the standard deviation problem. So our range was 24, right? That was the range. Our standard deviation was 8. So that doesn't make any sense that our range could be larger than the standard, or the standard deviation could be larger than the range. Because the closer the range it gets, the smaller the standard deviation will most likely be, because the numbers won't be as big. So this does not make sense. The standard deviation cannot be larger than the range. Okay? Because as the range gets smaller, so will your mean. So that means that as your mean gets smaller, it will make everything else. So it cannot be larger. There's just no way for it to happen that way. All right. So for this section, we have another activity for you to do. We've got, we did a box and whisker plot, right? So Box and Whiskers, you're going to figure out, looking at this picture, figuring out what the different parts of your data is. Which one's the median, the minimum, the max, the first quartile, the third quartile, and what's the range. Doing the range, I want to see some math there. Then you're going to find the 5-number summary, so you're going to have to put it most likely into numerical order to find that. Well, you're going to have to. In order to find the median, you got to put them in numerical order. So put that in numerical order, and then find all of the parts, and then create a box and whisker. So here's a line, make some marks on there, and label. Got to find the mean of this, so you got to show the work of adding all that together and then dividing by however many there are, find the mode, and find the range. So these down here, you're working off of this data set. So this is all number 2. This up here is number 1. You're not going to use these numbers down at the bottom part. All right? So do part 1 and then do part 2. And it's just a one-sided deal. Also, do your homework, because you've got homework coming up and you'll need to do that as well. There will be an activity coming up where you're going to find the standard deviation, but it'll be coming up here in a little bit. It may be in the same week, since this is a summer course, that you'll be finding the standard deviation on there, and then you're going to flip it over and do some more, but we haven't talked about the rest of that yet. So I'm not thinking you'll start with that. But you'll also have the range rule of thumb on this one as well. Okay? But if it's open in the week that you're doing this, you can go ahead and get started if you want until we do the other set of material that you need to understand in order to do that.